Welcome back to Learning to CAD with Autodesk Inventor. In this episode, we're going to quickly go over some assembly tips and tricks that I have for you to help speed up your CADing process and make your CAD more accurate. So to start off, if you haven't noticed in your time CADing or in these tutorial videos, your recent files will appear in this box here. If you hover over one, it will pop up with these three options. If you click the trash can, it won't delete it. It'll just remove it from your as you can see, remove from the list of recent parts. Or you can click the folder to open it. And our first tool we're going to go over is the measure tool. We're going to right click in the open space and go up to measure. And then if we click on this line, we can figure out the length of that line. If we click on this line to this line, we can figure out the length of that gap. And if we click on this line to this, oh, not the face. Oh, not that. Click on this line to this line, they're on different planes, so the angle, the measurement will actually be a diagonal from the two lines. If you want to find just the gap between these two without having to specifically select the top edges, you can just first deselect and then click on the faces that are facing one another, and you'll get a distance from those two faces. Or you can just select one face, as I'll show you here. Select that face and click on this edge. It will still give you the horizontal dimension. When you're trying to measure circles, however, you can actually measure one dimension, and then you'll see this box pops up called delta. Mine's open by default, but if you close it, if it's open, you can close it and open it, and it will pop up how I'm going to show you in a moment. Otherwise, it'll just show up like this, and you can expand it, and the deltas will show up. However, because these two, here, let me just select this. Now let's open the delta again. As you can see, we have now two different dimensions instead of one diagonal dimension. So before we had a dimension going from here to here, now we have two z and y dimensions. And it will also show up x, but because these two are on the same plane, it doesn't. Let's click on that edge and this. And x still didn't work, but if we last try, click on that and that. There we go. Now we have an x. As you can see, you'll get your x, y, and z dimensions instead of just diagonal dimensions. So also, when you're using the measure tool, so we can easily see things, click from there to there. And then when using the measuring tool, I like to open this drop down for precision under advanced settings. It'll show up like this with advanced settings minimized, but if you expand it, go to precision, the precision drop down, go all the way down to all decimals, you can see every decimal in that number. Now, this brings me to my second point. When we're working with Tetrix, it's a millimeter based system, so this inch dimension is very crazy, and I'd hate to be someone who has to make this if it weren't for all the easily mountable holes in the design. Oops, I didn't need to do that. So with the measuring tool, first of all, we can go dual units and make it millimeter. So now that is a 290 point whatever that is gap, which really you could just say it's 290 millimeters, because that 000 etc. 17 millimeters isn't going to affect your design whatsoever. It may affect your CAD, so you might need to keep using that number, but for your design, we don't need that number. You can also change that to feet, 0.951 feet, or whatever else in this list, micron, if you really want to measure it in micron, or just none, and it'll go back to how it was. You can also change the precision of angles if you want to do that. But when you're working with Tetrix, I would try to make everything, all of your part files in millimeters, just because then your base dimensions, when you click the measure tool, are already in millimeters. But if not, it really doesn't matter. Just add this dual units and it'll save it for as long as you need. Until you say no more dual units, I guess is a better way to put it. So you can see, like that. It's more of a random number at this point because the two lines are a lot farther apart. Like as you can see, this is the best example I like to look at. Let's just take dual units away really quick. If we dimension these two, it's a really random inch number, But if we add the dual units, it's only, let's see where to go. Scroll up. There it is. It's only 8 millimeters apart instead of the 0.314, etc. digits of the inch dimension. So let's say, on to my next tip. So let's say we're trying to center this cube on the robot. We could easily dimension it, or not dimension, we could easily constrain it to this to make it centered. But to show you an awesome quality about Inventor, first we're going to measure, I think I already know what this is, but 288 millimeters and 25.4 millimeters. So, just quickly make it easier to see by doing this. Now we're going to add a flush constraint between these two. This isn't the part I want to show you. It's this part. Autodesk Inventor will do your math for you. So we've typed 288, and then if you add, you have to add units if you're not working in millimeters as well. That's another reason to use millimeters. 288 minus, we can just do 1 because it's already default to inches, and then add a parentheses and then divide by 2. As you can see, it moved it to the exact center, so the center of this cube is also the center of this channel. But Inventor did the math for me, and with the proper syntax for your math, so PEMDAS or GEMDAS or GERMDAS, whatever you want to call it, it does exactly what you need it to do. You don't have to get out a calculator or anything. Sometimes you need a calculator just so you can do a little more complex math, but this works for now, for most purposes. You can't square anything in here, so it's a little difficult in that aspect. So the closer you can get your CAD to 100% accurate, the better. There's no way it'll ever be 100% accurate if your mechanical team is anything like every mechanical team ever, because especially with FTC, screws can go in different places and it really won't affect the design at all. But the closer you get it to accurate, the better. And then if you can CAD before you start building, that's way preferred to CADing as you're building. So this is an example of my first year of FTC. This robot CAD and this robot. As you can see, it's pretty accurate, except for obviously the electronics in the back and this number plate. But other than that, that's all I can really notice for the differences. But this was a robot that I CAD'ed as we went, and as a result, the robot tended to do wheelies because all the electronics were in the back, which means there's a lot of weight in the back, which is also directly over some motors. However, the next year, I CAD'ed sort of before, quite a bit before we went. Let's scroll up a little bit. You can see the design process. This was kind of a pointless design. I don't really know why I made that. But from here, I kind of had this design before we started building, but then we built this and then we're kind of adding on, and then that's sort of when I started to follow along with what the mechanical team was already doing to make the design. So this is a pretty accurate design. It really didn't have too many problems, but it sort of stemmed from this original design where the electronics were on top. It's nice to have the expansion hubs and control hubs because it's a much more consolidated electronic system. That being said, don't waste your time CADing screws and things until you're sure of what your design is going to look like as far as the concepts go. So let's say this is my drivetrain for now, but my team is like, oh, we hate it. So you take this bar and you move it to the back. I'll just do this really quick. I'll add another bar in front here and move this one to the back. Okay, so I've moved the channels like I said I was going to. And now that my team is like, oh, we like this better, I'm going to add the screws in. Because in FTC, the screws are pretty important because if let's say you put 2 screws here and here, then it's a lot easier to put 2 screws in this center area instead of over here because you'll have more finger space to get a kept nut on the back. As well as the screw heads tend to interfere with certain mechanisms, so it's easiest to put these in and then either design around them or move the screw so that you can make your mechanisms function. Oh, another thing I noticed while I was going through this was I haven't mentioned yet how if you select a couple parts that are already constrained together and then Control-C, Control-V, it will take all the parts and copy them and paste them obviously, but your constraints will also be pasted. So as you can see, my constraints that I applied to this are still there. So I can then take this and put it back in the middle if I want to do that. but we're gonna get rid of this for now. Control Z to undo. And the last thing I want to cover is making sketches in assemblies. So very similar to sketching parts for, let's say, like our cube and the making that one channel smaller in the second episode, I believe. We can make sketches in assemblies by going over to the Sketch tab, clicking Start 2D Sketch, and selecting whatever face you want to make a sketch on. And just for this example, let's pretend these wheels are actually like a sprocket. We're going to go click Project Geometry, click on this circle and this circle. With sprockets, it's a little more, you have to select the right things to make this work. But then we can go take this line, go from here to here. There we go. And then use one of our constraints to make these tangent. Come on, there we go. And then that one's already tangent. And then from here we can finish sketch, right click, copy, and then go open a new part file, paste it in there, and extrude the shape if we want to make a chain placeholder. Which, by the way, a chain placeholder works way better than actual chain links because it's much more manipulatable and you can still have your chain in the CAD. That's one thing I would very much recommend having in your CAD because it prevents taking the time to build the mechanism and then having your chain trying to run through some other thing like a motor. So that's it for this episode. In the next episode, we're going to go over a little bit of an extra bit. It's not necessarily related to CAD. It's more related to a team working on CAD and a little extra website.